Okay. The next topic is the VHDL models for multiplexer. In this chapter, how to write VHDL code for the multiplexer. We already know about how to represent 2:1 multiplexer for the representation in the block diagram and equation for the multiplexer. For 2:1 multiplexer is the 2 data input and 1 control input. For this, the mux output is expressed by using equation is f is an output, f is equal to a dash into I naught plus a into I1. See, f is an output line, I naught and I1 your data line, and a is your control input. For this equation, I can write by using VHDL statement. The normal VHDL statement can I write in the easiest ways. The f is less than or equal to, because of a dash, the a dash can be represented as not of a, and dot is concatenation operation between a dash and I naught. Because of that, I can write not of a and I naught. Then plus, the plus is replaced with the syntax is or. The next is a dot I1. A is concatenated with I1. Then a and, because of dot I replace with and, the second data input is I1. Okay, this is the one of the form I can write VHDL statement. Okay, now we can study for the what is the different way can write VHDL code for the same equation. Okay, this is the simplest way. Okay, this you can also write the same represent by the mux conditional signal assignment statement. Okay, that this statement executes whenever a and I naught or I1 changes. The mux output is I naught when a is equal to 0 or else it is I1. See, as the name indicates, I can also use conditional statement. If you apply a condition, according to that you can execute. Here each and everything should be written in only one statement line. But the next you can also write the same 2:1 by using conditional statement. What is that by conditional statement and how can we represent? See, this is the first one is the general method. F is less than or equal to not of a and I naught or a and I1. See, this is the block diagram of 2:1 multiplexer. I naught, I1 is a data line and F is an output line. A is your data select line. If A is equal to 0, F is equal to I naught. A is equal to 1, F is equal to I1. Okay, this can also written by using the second method is conditional signal assignment statement is F is less than or equal to I naught when A is equal to 0 or else I is equal to 1. See, when A is equal to 0, then F value should be I naught or else that I1 should be stored in F1. Okay, this is called conditional signal assignment statement. And what is the syntax for conditional signal assignment is, you can see here, the conditional signal assignment, that is a signal underscore name is the syntax for the variable declaration for the output, less than or equal to expression 1. This is then what is the input, it should be passed that. If condition is true, expression 1 is assigned to signal name. Then signal underscore name less than or equal to expression 1 when condition 1 is true. If condition 1 is false, else it's go to expression number 2 or else expression number 3 or else go for expression number n. Okay, this is the syntax for conditional signal assignment. The same procedure we are using to write 2:1. You can also use the same procedure for 4:1 or 8:1 multiplexer also. Okay, now you can go for the second type of problem is, the previous problem is I am taking only one 2:1 multiplexer. Now you can check with cascaded of 2:1 multiplexer using data flow model. Okay, now we can consider we have a 2 mux. The 2 mux are cascading with one to one another. And how can you write the VHDL code for F? See the diagram. The diagram have a 2:1 multiplexer. 2 multiplexer is there. The first multiplexer C and B is your data line. D is your select line. And the second one is 0 and 1 is your input line. A is your data line and this is E is your select line, F is your output. Okay, now the E value is 0 and 1. We can check what is an F. E value is equal to 0, then the output is what? F is equal to what? The output of the first multiplexer. E value is equal to 1, then you will get the output of this, and A is also considered. See, that only I am writing in the VHDL code. Okay, see, the fill of shows has two cascaded mux can be represented by conditional signal assignment statement. The output mux select A when E is equal to 1. The E is equal to 1, the output overall cascading mux output will become the F, or else it selects the output of the first mux when is B when D is equal to 1. See, when D is equal to 1, then B is the answer, B is move on to E, then that E and A combination, if E is equal to 1, you will get an F. Or else the D value is 0, then the first multiplexer C is an output. Okay, now that C and A will be combination, you will get the final output. See, that I am writing in this code. F is less than or is equal to A. See, observe, the F is less than or is equal to A when E is equal to 1, else B when D is equal to 1. If it is D value is 1, that answer is what? B, or else is equal to C. Okay, this is called cascading of two